Well, greetings and welcome to our lesson today on complex numbers. Once again, I apologize for this raspy voice. Hopefully this cold will go away soon and you won't have to turn your volume up every time you get ready to listen to one of these. Today we talk about the complex numbers. We are reminded of the definition here. I is equal to the square root of -1, and so if we square both sides here, we see that I squared is equal to -1. When we look at a complex number, we have a real part, we have an imaginary part. We always write complex numbers in what we call the standard form, a plus bi, where we put the real part first and then the complex part in the back. Now, adding and subtracting complex numbers works maybe just the way you would think it might. -3 plus 8i minus 2 minus 3i. We combine like terms, -5 plus 5i, and there we go. Our second example has us square out this binomial. Remember, this is 6 plus 7i times 6 plus 7i. We multiply here, 6 times 6 is 36, plus 42i, plus 42i, plus 49i squared. So we have 36 plus 84i plus 49 times -1. We get 36 minus 49 plus 84i, getting this in standard form. 36 minus 49 is -13 plus 84i. So this is how we multiply two binomials together where they are complex numbers. You can see I've asked you to work problems 2 and 14 for class discussion and then the list for the homework. Now, we do not want i's in our denominator, and so to get rid of that, we have the complex conjugate. If we have a number a plus bi, its conjugate, which is denoted by this z bar, the complex conjugate, is a minus bi. So how's that going to work? Well, we're going to multiply top and bottom by -3 plus I. Okay? And so we have -6 plus 2i minus 27i plus 9i squared. This is all over 9. Notice how these middle terms drop out. Minus 3i plus 3i minus i squared. And so we get ready to combine like terms on top. -6 minus 25i plus 9 times -1 all over 9 minus a -1. Okay. -6 minus 9 minus 25i all over 10. This gives me -15 minus 25i. Both of these are over 10. So -3 halves minus 5 halves I. And so that's how you divide complex numbers. I've given you a couple problems in 20 and 26 for you to prepare as you get ready for class discussion. And then I've asked you to work these 3 problems for homework. Now, we get ready to solve equations that have imaginary roots in them. And as we prepare to do that, we work on simplifying expressions that involve these complex numbers. If you look at example 4, which is problem 30 from your homework, -3 plus 5i times 8 minus 6i. All right. And we get ready to multiply here. -24 plus 18i plus 40i minus 30i squared. -24 plus 58i minus 30 times -1. Well, we think about what this is, negative 24 plus 58i plus 30. Remember what we've got is 6 plus 58i. And so we remember to write our answer in standard a plus bi form. The real part first, the imaginary part second. If we look at example 5 here, we need to first simplify this. This is 2 minus 9i over 3 plus 6i. Because the square root of negative 81, I can write that as the square root of 81 times the square root of negative 1, which is 9i. Square root of negative 36 is the square root of 36 times the square root of negative 1, which is 6i. We're going to multiply top and bottom by the conjugate of the bottom here. Okay, so let's see, we have 6 minus 12i minus 27i plus 54i squared all over 9. Notice the outers and the inners are going to drop here. I'll show this one more time. Minus 18i plus 18i minus 36i squared. So 6 minus 39i plus 54 times negative 1 all over 9 minus 36 times negative 1. Well, 6 minus 54 minus 39i all over 9 plus 36. 9 minus 54 is negative 48 minus 39i over 45. And then we can reduce negative 16 over 15 minus 13 over 15i. And so we continue looking here at this. If you have questions, please bring them with you to class. For class discussion, I'll ask you to work problem 34. Now, we are ready to solve some equations that involve imaginary roots. If we look here at example 6, which is problem 44 from the set, we will notice here that we have a quadratic equation. It will not factor. So we can go to the quadratic formula. X equals the opposite of 3. Plus or minus the square root of 3 squared. Minus 4 times a times c. All over 2 times a. Negative 3 plus or minus the square root of 9. Minus 24 all over 2. Gives me negative 3 plus or minus the square root of 9 minus 24 is negative 15 all over 2. And then we can rewrite this as negative 3 plus or minus I root 15 all over 2. And we can split this up if we want to. Make sure, folks, that your I is not under the radical, please. I'll have to take off points if it is, because if the I were under the radical, you know, if I had something like the square root of 15i, this would be the square root of 15 times the square root of negative 1, and that's not what we want. If we look at example 7, we have the difference of cubes. We recognize right away. We know how that factors. And so we can factor that. And then what we notice is that we can set each factor equal to 0. Well, one of these equations is quite basic to solve. X equals 3 is my solution here. Here, though, I can't factor. I will use the quadratic formula. negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. This equals negative 3 plus or minus the square root of 9 minus 36 all over 2. Negative 3 plus or minus the square root of negative 25 all over 2. We know that the square root of negative 25 is 5i all over 2. And we can leave our answer like that. If you want to split it up, negative 3 halves plus or minus 5 halves I, that is certainly okay as well. One more example here to look at. This is problem 56 from your problem set. Here we've got a 4-term polynomial, and so we're going to try to factor this by grouping. Let me try the first two together. I see I can take a 4x squared out. That's going to leave me with 2x minus 3. I see here I can always take a 1 out. Don't forget about that, folks. That'll leave me with a 2x minus 3. Then what's in common is 2x minus 3. What's left over is 4x squared plus 1. Set both of these equal to 0. Okay, so x equals 3 halves, and x squared equals negative 1/4. Of course, we have our solution here. We're going to take the square root of both sides. Please don't forget about the plus or minus. And so we know the square root of negative 1 is I. Square root of 4 is 2. And there we have our 3 solutions. 3 halves, I over 2, and negative I over 2. For class discussion, I'm going to ask you to work 40, 46, 55, and then for homework, 39, 41, 42, 47, 48, 52, 53, and 54. So bring all your questions and be ready for our class discussion.